Good afternoon. So today we will see the programming related to 8051. So here is a program of interfacing 7 segment with 8051. So to display the numeric values, we can use the 7 segment display. 7 segment display is used to show the numeric values. So first we have to interface a 7 segment to 8051. To display the values, we have to use the 7 segment display. And first we have to interface the 7 segment display to 8051 and then display a single digit decimal counter that is 0 to 9, and then later the same will be extended to multiplex 4 7 segment display to generate 4 digit counter. Okay, so this is the basic procedure. First we have to use the 7 segment display to display the number. First we have to interface the 7 segment to 8051 and we have to display a single digit decimal counter that is in between 0 to 9, and then we will extend it to the multiplex 4 7 segment display to generate a 4 digit counter. So first we will see what is 7 segment display. So the name 7 segment shows that there are 7 LED segments which are arranged and which is shown in this figure. This name shows that there are 7 LED segments. After the LEDs, these are the easiest interface to a microcontroller. After LED, these are easiest interface to microcontroller, and there is also decimal point or DP, and it is used when decimal digits like 5.1 etc. are displayed. After LED, these are the easiest interface to microcontroller. There is a decimal point which is shown here in this diagram denoted by DP, and it is used when decimal digits like 5.1, 4.1, for this purpose this DP is used. The next is the applications. So where these 7 segment displays are widely used? These are widely used in applications where the digits 0 to 9 are required to be displayed, although they are also display a letter A to F simulation, and this is very simple and convenient to display numbers in bright fashion. So here the form factors are given, so they come in various sizes which are given here, and the colors for these are also given here. Now working of this 7 segment display, as these are basically LEDs which are arranged in, since these are basically LEDs which are arranged as a group, they can either have the anode in common or cathode. So they are named as common anode or common cathode display. As these are LEDs which are arranged in, as these are basically LEDs which are arranged as a group, and it can either anode as a common or cathode as common. So they are named as common cathode or common anode. Now the diagram for the common anode and common cathode are shown here. So in the in common cathode type, the segments all in this, that is common cathode type of the segments, all the cathode terminals are made common and tied to the ground. Common cathode means all cathode terminals are made common and tied to ground. So a segment A, which is shown in the diagram, to segment G, it needs a logic high, that is 5 volt signal to glow. And common anode, in this type of the segment, all anode terminals are made common and these are tied to VCC, that is 5 volt. So the segments A to G needs a logic low signal to glow. For common cathode, cathode are connected to the ground and the terminals A to G to the high logic, that is 5 volt. And in common anode, anode of all anodes are connected to the 5 volt and the segments A to G are connected to the low signal, that is ground. Now this is the diagram. Common anode. Common anode means the anode has given a common plus 5 volt, or we can say a high voltage. So the table which is shown here, it shows the binary or hex values for displaying the digits on a common anode 7 segment display. So here is the table which shows the binary or hex value for displaying the digits on common anode. Common anode means what? All the anodes are connected to plus 5 volt, that is VCC, and the cathode pins, that is A to G, these all are connected to the ground, that is low. So here digits 0, 1, 2, 0 to 9 are shown. Then H, G, A, B, C, D, that means the lines which are used to denote the number. It shows, means for 1, for digit 0, all the lines are, that is A, B, C, D, E, F, all are 0, only the G and H are high. and its hex value is also given here. Similarly, for all the remaining digits, that is 1 to 9 are also shown. So this diagram shows which values are 0 and which values are 1. Hex values for all the digits are also given here. Now this diagram shows the hardware connection. Different pins of ports, that is P2.0, 1, 2, 3, 4, 5, 6, 7 for A, B, C, D, E, F, G, H are given, and for common it is VCC. So here are all the pins. This diagram shows the hardware connection. Now next is the code for single statement. So what we have to do, we have to write first the code to display a single digit up counter, and then we have to multiplex it to 4. So here is the diagram, or we here is the sample code to display a single digit up counter. So code is given here, void delay ms unsigned. So for I is equal to 0, I less than ms count, I plus plus, the loop is given. Then character segment code, the hex values are also given here. Then next is again the hardware connection for the 4 segments. Here is for the single segment and here is for the 4 segment. So now we have to write the sample code for multiplexing. So next is the code, that is sample code for multiplexing of 4 segments to display a 4-digit up counter. So previous was the code for a single segment, single digit up counter, and here is for the 4-digit up counter. So include, hash include, first is the define all the libraries, then void delay, then the hex values, character segment code hex values are given here. These all are for the 4-digit up, 4 are given. So in this way we can write the program. So this is the code for multiplexing a 4 segment to display 4 digit up counter. 4 segment to display 4 digit up counter. You just write down the program. Thank you.